Okay, so green 11. Yeah, so this is a direct calculation, but the setup, there's a couple steps here. So the problem says, theorem 633, excuse me, is that if you have a point x1, y1, and then the line segment over here to another point x2, y2, call that line segment L, going that way, then the line integral over that line segment, of x dy equals, according to this theorem, the average value of x times dy, delta y. So in other words, more specifically, that it's x1 plus x2 over 2 times y2 minus y1. That's what we're calling x bar, and this is what we're calling delta y. Okay, so you see what we're trying to prove? Yeah. And I claim we're going to brute force it. I'm just going to literally parameterize this line by brute force. I'm going to parameterize the line by saying, all right, well, x, namely xy, that's going to be x1, y1 plus t times x2 minus x1, y2 minus y1. There's a brute force parameterization. T goes from 0 to 1. Let me pause on that for a second. Does that make sense as to how that is a parameterization?
Yeah.
Okay. Everybody good? Alrighty then. So I could rewrite x is x1 times 1 minus t plus x2 times t, and y is y1 times 1 minus t plus y2 times t. That is, I don't know if off the top of my head, is this going to be convenient? I don't know, but I've always kind of liked this formulation of that parameterization, just because x1 goes there, x1 and y1 go here, x2 and y2 go here, and you just remember that these get multiplied by 1 minus t, these get multiplied by t. And what's kind of cool about this, you can sort of see this coming, kind of, because when t equals 0, that goes away, and that goes away, and you have just x1 and y1. When t is equal to 1, that goes away, and that goes away, and you end up with just x2, y2. I think it's kind of cool. Well, whatever. Okay, so, all right, back to business. So we're computing now an integral over this line of x dy. Okay, here's x. Now, dy, okay, here's y. So dy is going to be the t derivative of this, which is, of course, y2 minus y1 dt. What's the range of values for t? Well, in this parameterization, t goes from 0 to 1, so 0, 1. And now you have just a brute force calculation to do. And I claim if you crank this out, then it will simplify to this, which you can interpret as that. Is that cool? Everybody happy with this? I'll let you fill in the details. Okay. Yeah, brute force problem. But you do have to sort of, sometimes brute force problems have enough steps in them that, taking that first step kind of seems like, well, I don't know, there's a lot of work in that first step, and I'm not sure where I'd go there. And students sometimes hesitate to take that first step. But in some of these brute force problems, you just literally have to brute force them. Okay, all right.